What if the next automotive revolution wasn't coming from Silicon Valley, Detroit, or Germany, but from China? For decades, Western automakers dominated the global car industry. Companies like Tesla pushed electric vehicles into the spotlight, while traditional manufacturers raced to catch up. But while the West was busy debating battery range, charging networks, and EV adoption, something else was quietly happening on the other side of the world. China wasn't just building electric cars. It was building an entire ecosystem designed to control the future of the automotive industry. From batteries and motors to raw materials and charging infrastructure, Chinese companies were preparing for a future where they could produce powerful, affordable electric vehicles at a scale the rest of the world would struggle to match. And now that strategy is starting to pay off. Today, companies like BYD and CATL are reshaping the EV industry faster than many experts predicted. But the most surprising part of this story isn't just how fast China's EV industry is growing. It's how long this strategy has actually been in motion. Because the truth is, China didn't suddenly decide to dominate electric vehicles. The groundwork for this shift began decades ago, during a crisis that forced the country to rethink its entire energy future. And what happened next changed the global auto industry forever. In the early 2000s, many of China's major cities were facing a serious problem. Massive economic growth had transformed the country into a manufacturing powerhouse, but it also created a severe pollution crisis. Cities like Beijing and Shanghai were regularly covered in thick smog, and air quality became a growing health concern for millions of residents. At the same time, China was becoming increasingly dependent on imported oil. As the country's population grew and more people began purchasing cars, fuel demand skyrocketed. This created both economic and strategic challenges. Relying heavily on foreign oil meant that energy security could become a serious vulnerability in the future. So China's leadership began asking an important question. What if the country could skip the traditional gasoline era altogether? Instead of trying to compete with Western automakers in internal combustion engines, China decided to focus on something different: electric vehicles. At the time, many people thought the idea was unrealistic. Early EV technology had major limitations. Batteries were expensive, charging stations were almost non-existent, and most electric cars had limited driving range. But China saw EVs not as a short-term solution, but as a long-term strategy. In 2001, the government launched the 863 program, which focused on investing heavily in advanced technology sectors, including electric mobility and battery research. Subsidies, tax incentives, and funding programs were introduced to encourage companies to develop electric vehicles. But China did something very different from Western countries. Instead of focusing first on private passenger cars, it began electrifying public transportation. And one city would soon become the most powerful example of this strategy in action. The city of Shenzhen decided to attempt something that had never been done before. It planned to convert its entire public bus fleet to electric power. This was an enormous challenge. Buses operate almost constantly throughout the day, traveling long distances while carrying heavy passenger loads. If electric vehicles could handle that level of demand, it would prove that the technology was ready for widespread adoption. And the results were remarkable. By 2017, Shenzhen had converted nearly 16,000 buses to electric power, making it the first city in the world to operate a fully electric public bus fleet. This wasn't just a local transportation upgrade. It was a global demonstration. Cities around the world suddenly realized that electric vehicles could operate reliably at large scale. Pollution levels dropped, fuel costs were reduced, and public confidence in EV technology began to grow. But China didn't stop there. Soon after, the government introduced another powerful policy known as the dual credit system. This rule required automakers to produce a certain percentage of electric vehicles. If companies failed to meet the targets, they were forced to purchase credits from competitors who exceeded them. In other words, manufacturers had two choices: build electric vehicles or lose money. The result was a rapid surge in EV development across the country. But while these policies helped stimulate the EV market, China was also quietly building something even more powerful behind the scenes: control over the entire electric vehicle supply chain. Electric vehicles rely on one critical component more than anything else: the battery. Without advanced battery technology, EVs simply cannot compete with gasoline vehicles in range, cost, or performance. And China understood this early on. While many Western companies focused primarily on vehicle design and software, Chinese firms invested heavily in battery production and raw materials. Over time, companies like CATL became some of the largest battery suppliers in the world. Today, batteries produced by Chinese companies power vehicles from numerous global automakers. But China's strategy extended even further. The country also invested in mining operations and supply agreements across Africa and South America to secure key materials such as lithium, graphite, and cobalt. By controlling both battery manufacturing and the supply chain behind it, China positioned itself as a central player in the EV industry. And then one company pushed this idea even further. BYD is one of the most fascinating companies in the automotive world today. Unlike many automakers that rely heavily on external suppliers, BYD built a business model based on vertical integration. That means the company produces many of the critical components used in its vehicles internally. Batteries, motors, electronic control systems, and even semiconductor technologies are developed in-house. This approach gives the company a major advantage. When manufacturers rely on multiple suppliers scattered across different regions, costs increase and production becomes more complicated. But when a company controls most of the process itself, it can dramatically reduce costs while improving efficiency. One of BYD's most important innovations is its blade battery. This battery design uses lithium iron phosphate chemistry, commonly known as LFP. Unlike other battery types that require expensive materials such as cobalt, LFP batteries rely on more abundant and affordable resources. They are also considered safer and less prone to overheating. Lower costs, improved safety, and longer lifespan made this technology extremely attractive for large-scale EV production. But batteries are only one part of the equation. The motors powering these vehicles are just as important. And that's where things get even more interesting. Electric motors operate very differently from gasoline engines. Traditional engines rely on complex systems involving fuel combustion, gear changes, and thousands of moving parts. Electric motors, on the other hand, are far simpler. They deliver power almost instantly. Many Chinese EV manufacturers use a type of motor known as a permanent magnet synchronous motor. This design allows vehicles to generate strong torque immediately when the accelerator is pressed. The result is rapid acceleration and highly efficient power delivery. Take vehicles like the BYD Seal, the BYD Atto 3, and the compact BYD Seagull. Each model targets a different segment of the market, from affordable city vehicles to high-performance electric sedans. Yet they all share a common technology foundation: fast acceleration, efficient motors, and relatively affordable pricing. And this combination has started to attract global attention. But while electric vehicles promise a cleaner future, the reality behind battery production is more complicated than many people realize. Electric vehicles are often promoted as a solution to pollution and climate change. Because they produce no tailpipe emissions, they can significantly reduce air pollution in urban environments. However, producing the batteries used in EVs requires large quantities of raw materials. Lithium extraction, for example, can require enormous amounts of water. In some regions, millions of liters of water may be used to produce a single ton of lithium. This has raised environmental concerns in parts of South America, where water resources are already limited. Another controversial material is cobalt. A large portion of the world's cobalt supply comes from the Democratic Republic of the Congo, where mining operations have faced criticism over environmental damage and labor conditions. As EV demand grows, these issues have become part of the broader discussion surrounding electric mobility. To address these challenges, many companies are investing in battery recycling and alternative battery chemistries that reduce dependence on controversial materials. Technologies like lithium iron phosphate batteries have already helped reduce the need for cobalt. But the next major leap in EV technology may come from something even more advanced: solid-state batteries. Today's electric vehicles rely mostly on lithium-ion batteries that contain liquid electrolytes. These batteries work well, but they have certain limitations related to energy density, charging time, and safety. Solid-state batteries aim to replace the liquid electrolyte with a solid material. This seemingly small change could have enormous implications. Solid-state batteries could potentially store more energy in a smaller space, increasing vehicle range significantly. Some experts believe EVs using this technology could eventually travel 700 to 800 kilometers on a single charge. Charging times could also be reduced, making electric vehicles even more convenient for long-distance travel. Several countries are racing to develop this technology, including the United States, Japan, and Europe. But China is investing heavily in this area as well. Companies like CATL and BYD are conducting extensive research into next-generation battery systems. If these companies succeed in bringing solid-state batteries into large-scale production, the global EV landscape could shift once again. And that could put China even further ahead in the race for automotive dominance. The global car industry is now entering one of the most dramatic transitions in its history. Electric vehicles are rapidly becoming mainstream, and new technologies are reshaping how cars are designed, manufactured, and powered. But the biggest shift may not just be technological, it may be geographic. China's strategy of combining government policy, massive investment, supply chain control, and manufacturing scale has created an EV ecosystem unlike anything the world has seen before. Companies like BYD are expanding rapidly into Europe, Asia, and Latin America. Battery manufacturers are supplying automakers across multiple continents, and new technologies are emerging at a pace that continues to surprise the industry. The real question now isn't whether electric vehicles will dominate the future of transportation. That part seems increasingly certain. The real question is something much bigger. Who will lead that future? Because if current trends continue, the next chapter of the automotive industry may not be written in Detroit, Silicon Valley, or Germany. It may be written in China.